Section 1. The Unchallenged Domain. In the vast, cold expanse of the European sky during the early 1940s, there was a prevailing truth, a stark reality understood by every airman who dared to cross the channel. The sky belonged to the Luftwaffe. This was not a matter of opinion or propaganda. It was a fact written in trails of smoke across the clouds, in the silent, empty spaces, in returning bomber formations, and in the grim statistics tallied day after day in briefing rooms across England. From the onset of the conflict in 1939 through the long, arduous months of 1942, the German Air Force had forged a dominion built on superior technology, battle-hardened tactics, and a cadre of exceptionally skilled pilots. Their primary instruments of control were machines that had become legends in their own right. The Messerschmitt Bf 109, a nimble and deadly fighter, and the Focke-Wulf FW 190, a radial-engine brute that pilots called the Butcher Bird for its sheer destructive power. These fighters, flown by men who had honed their craft over the skies of Spain, Poland, and France, were the apex predators of this high-altitude battleground. The strategic arm of the Luftwaffe, with its fleets of Heinkel He 111 and Junkers Ju 88 bombers, had already demonstrated its capacity to project power and sow devastation. But it was the fighter arm, the Jagdwaffe, that maintained the iron grip over the continent. By 1942 and into 1943, this dominance had been personified by a new generation of aces, pilots whose names were spoken with a mixture of awe and dread. Men like Hans-Joachim Marseille, whose uncanny marksmanship was legendary, and Erich Hartmann and Hermann Graf, pilots who would eventually amass staggering tallies of aerial victories, became the living embodiment of the Luftwaffe's supremacy. Their method was a cold, calculated science of interception and destruction. They studied the lumbering formations of Allied bombers, identifying their weaknesses, their blind spots, and the precise moments of their vulnerability. They learned to attack from the glare of the sun, to dive at speeds that made them nearly impossible to track, and to use the formidable firepower of their aircraft with devastating efficiency. For the crews of the American 8th Air Force, flying their missions from bases in eastern England, this reality was a daily trial of courage and endurance. Their weapons were the Boeing B-17 Flying Fortress and the consolidated B-24 Liberator. These were magnificent aircraft, technological marvels designed to be resilient, heavily armed, and capable of carrying a significant payload deep into enemy territory. The very name, Flying Fortress, was meant to evoke an image of impregnable strength, a self-defending platform bristling with .50 caliber machine guns. In theory, flying in tight combat box formations, these bombers were supposed to create overlapping fields of fire, a protective web of steel that no fighter would dare to penetrate. In practice, however, the German aces proved that this fortress was far from impregnable. They developed tactics to break the formations apart, isolating individual bombers and subjecting them to concentrated, overwhelming attacks. The journey into the heart of the German Reich was a long and perilous one. The bombers, laden with fuel and their destructive cargo, were slow and ponderous compared to the swift interceptors that rose to meet them. The critical flaw in the Allied strategy was the problem of distance. The bomber crews were flying a journey of 1,000 miles or more, a round trip that could take 8, 9, or even 10 hours. For a significant portion of that journey, they were utterly alone. Their fighter escorts, the guardians meant to protect them from the wolves of the Luftwaffe, simply could not go the distance. The early Allied fighters, while effective in their own right, were tethered to their home bases by the limitations of their fuel capacity. They could provide cover over the English Channel and the coast of France, but as the bomber streams pushed deeper into Germany, a dreaded moment would inevitably arrive. The fighter pilots would waggle their wings, a silent, heartbreaking farewell, and turn for home, their fuel gauges dictating the end of their protective watch. From that moment on, the bomber crews were on their own, flying deeper into a sky that grew more hostile with every passing mile. The Luftwaffe knew this. They had a sophisticated system of radio intercepts and early warning radar that allowed them to track the Allied formations with precision. They could afford to be patient. They would wait, conserving their fuel and positioning their squadrons, allowing the bombers to penetrate deep into their airspace, far from the reach of any friendly fighters. Then, when the bombers were at their most vulnerable, tired, and strung out, the attacks would begin. The experience for the bomber crews was a unique form of psychological torment. They were confined in a cold, vibrating aluminum tube, thousands of feet above an unwelcoming landscape. The air was thin, the cold so intense that it seeped through their electrically heated flying suits. They breathed canned oxygen through rubber masks, their world reduced to the crackle of the intercom and the endless drone of the four engines. They were not just soldiers, they were technicians, navigators, bombardiers, and gunners, each man focused on his specific, intricate task. But they were also watchmen, their eyes constantly scanning the brilliant, unforgiving blue, searching for the tiny black specks that would signal the beginning of the ordeal. When the specks appeared, they grew with terrifying speed, resolving into the sleek, menacing shapes of the German fighters. The controlled calm of the aircraft would shatter. The intercom would come alive with urgent call-outs. Fighters at 3 o'clock high. The air would be filled with the percussive rhythm of the heavy machine guns, the smell of cordite, and the sight of tracer rounds lacing the sky. The German pilots, unencumbered by the need to fly in a rigid formation, attacked with a deadly grace, a choreography of high-speed passes and climbs that was almost impossible to counter. The bombers, locked into their course, could only press on, their gunners doing their best to fend off the relentless assaults. For every German fighter that was deterred or damaged, another seemed to take its place. The sky, which had seemed so empty and peaceful moments before, became a three-dimensional arena of chaos and conflict. The cost of this strategy was staggering. During this period, the 8th Air Force frequently suffered loss rates that were unsustainable. On some missions deep into Germany, as many as 1 in 4, or even 1 in 3, of the participating aircraft would not return. Each loss was not just a machine. It was a crew of 10 men, a small, tightly knit family that had trained together, lived together, and now faced the ultimate test together. The empty bunks in the Nissen huts, back at base, were a silent, daily reminder of the price being paid to maintain the strategic bombing campaign. The air war over Europe had become a brutal war of attrition, and it was a war the Allies were struggling to win. The flying fortress was a shield, but it was not enough. What the bomber crews needed, what they prayed for in the quiet moments before each mission, was a guardian, a shepherd that could stay with them for the entire journey, a sword that could reach as far as their own determined flight. They needed a long-range fighter, and in 1943, such a machine seemed like an impossible dream. The Luftwaffe ruled the skies, and the path to victory seemed to be vanishing into the endless, hostile blue. Section 2. The Fortress Without a Shield. The Boeing B-17, Flying Fortress, and the consolidated B-24 Liberator were the cornerstones of America's strategic bombing doctrine in the European theater of operations. They were born from a philosophy that believed a well-armed, high-flying, and tightly packed formation of heavy bombers could defend itself on long-range missions without the need for fighter escort. This concept, developed in the peacetime years, was about to be tested in the most unforgiving crucible imaginable: the skies over the German Reich. On paper, the theory was sound. The B-17, in its later variants, was armed with as many as 13.50 caliber Browning machine guns, strategically placed to cover nearly every angle of approach. When dozens, or even hundreds of these bombers flew in a combat box formation, a staggered, three-dimensional arrangement of aircraft. They were intended to create a fortress of interlocking fire. The sheer volume of defensive firepower from a single combat box was immense, a hailstorm of lead that, in theory, would shred any attacking fighter that dared to press its attack. The B-24 Liberator, while less celebrated for its durability, offered superior range, speed, and bomb load, and it too was heavily armed. The men who flew these magnificent machines were among the best trained in the world. They were a diverse collection of young Americans from every corner of the nation, united by a common purpose and an extraordinary sense of duty. The pilot and co-pilot wrestled the heavy aircraft through the skies. The navigator plotted a precise course across hundreds of miles of hostile territory, using little more than a map, a compass, and the stars. The bombardier was responsible for the mission's ultimate purpose, guiding the payload to its target with the aid of the secret Norden bomb sight. And then, there were the gunners, waist gunners, a ball turret gunner curled into a plexiglass sphere on the belly of the plane, a tail gunner isolated in the loneliest position of all, each man a sentinel, his eyes scanning the endless sky. A typical mission began long before dawn, in the cold, damp air of an English morning. The crews would be roused from their sleep for a breakfast of powdered eggs and coffee, followed by the main briefing. In a smoke-filled room, they would gather before a large map of Europe, a red line of yarn snaking from their home base to a distant, unfamiliar name in Germany. Intelligence officers would detail the target, the expected opposition, the weather, and the call signs for the day. It was a ritual of cold, hard facts, a process designed to strip away emotion and focus the mind on the technical challenges ahead. Yet, no briefing could ever fully prepare a man for the reality of the mission itself. The process of taking off was a thunderous ballet, as dozens of heavily laden bombers roared down the runways one by one, joining a vast aerial armada that circled for hours to assemble into formation. The climb to altitude was slow and laborious. As the aircraft ascended, the temperature inside the unpressurized fuselage would plummet, often reaching 30 or 40 degrees below 0 Celsius. The crew members would plug into the aircraft's electrical system to power their heated suits, a fragile defense against a cold so profound it could freeze machinery and numb the mind. At 10,000 feet, they would don their oxygen masks, beginning a reliance on a system of tanks and tubes that would be their lifeline for the next 8 hours. The journey across the North Sea or the English Channel was often deceptively calm, a period of anxious waiting. The real mission began when they crossed the enemy coast. This was the point of no return, the moment the little friends, their fighter escorts, would often have to turn back. The German defensive system was a masterpiece of lethal efficiency. It was a layered network that began with Freya and Würzburg radar arrays along the coast, which would detect the incoming bomber stream and relay its position, altitude, and heading to fighter control centers. As the bombers flew inland, they entered the domain of the flak batteries. The sky would suddenly be pockmarked with ugly black puffs of smoke, the calling card of the German 88mm anti-aircraft guns. Each puff represented a shell exploding at a predetermined altitude, sending a spray of red-hot shrapnel tearing through the air. A direct hit was catastrophic, but even near misses could be devastating, punching hundreds of holes in the thin aluminum skin of the aircraft, severing control cables, igniting fuel lines, or injuring crew members. The bomber crews had to fly straight and level through these flak belts, a gut-wrenching experience of being a stationary target for an unseen enemy on the ground. The pilots could not take evasive action, as they had to maintain the integrity of the combat box and stay on course for the target. They could only endure, listening to the metallic rain of shrapnel peppering their fuselage and praying that the next burst would not find them. But the flak, as terrifying as it was was often just the prelude to the main event, the arrival of the Luftwaffe fighters. They would appear as if from nowhere, vectored in by their ground controllers to the most advantageous position. Their attacks were a study in brutal geometry. The head-on attack became a favored tactic against the B-17. German pilots would fly directly at the bomber formation, closing at a combined speed of over 500 miles per hour. This gave the bomber's forward-facing gunners only a few terrifying seconds to acquire, track, and fire at the target before it flashed past. The fighters, meanwhile, would unleash a devastating volley from their cannons and machine guns, aiming for the cockpit and the flight deck, hoping to disable the pilots and send the 10-man aircraft spiraling out of control. The psychological strain on the bomber crews was immense. For hours on end, they existed in a state of hypervigilance, their lives dependent on a split-second reaction or a lucky break. They witnessed scenes of profound destruction. They would see a neighboring aircraft, a plane full of friends they had shared breakfast with that morning, suddenly blossom into a horrifying orange fireball. They would see another bomber, crippled and trailing smoke, fall out of formation, knowing that it was now a lone straggler, a doomed target for the circling fighters. The intercom, once a lifeline of professional communication, would carry the strained voices of men reporting damage, the urgent calls of gunners tracking incoming threats, and sometimes a sudden, chilling silence. The 8th Air Force's operational statistics from this period tell a grim story. The command had established a threshold for unsustainable losses at around 10%. For many months, especially on deep penetration raids to targets like Schweinfurt or Regensburg, the loss rates soared to 25, sometimes even 30%. These were not just numbers. They represented a catastrophic hemorrhaging of trained crews and expensive aircraft. The very viability of the entire American daylight strategic bombing campaign was called into question. The fortress, for all its guns and its crew's bravery, was not enough. It was a shield with a fatal crack. The men flew with a grim fatalism, calculating their odds of completing their tour of 25 missions. The odds were not in their favor. They were fighting a defensive war, reacting to the enemy's moves, their fate determined by factors far beyond their control. What they needed was a fundamental shift in the balance of power. They needed an avenger, a protector, an aircraft that could not only meet the German fighters on equal terms, but could do so over the skies of Berlin. They needed a friend to stay with them all the way to the target and all the way back home. The calls for such a fighter grew from a desperate plea to an absolute strategic necessity. The future of the air war, and perhaps the war itself, depended on finding a solution to the tyranny of distance. Section 3. The search for a guardian. The desperate need for a long-range escort fighter was not a new problem for Allied air commanders in 1943. It was the single, most critical challenge they faced. The doctrine of the self-defending bomber had been proven tragically flawed, and the very foundation of the strategic air campaign against Germany was crumbling under the weight of unsustainable losses. The search for a guardian angel for the bomber streams was a matter of extreme urgency, and Allied engineers and tacticians threw everything they had at the problem. The existing stable of American fighter aircraft consisted of formidable machines, each with its own unique strengths, but all sharing the same crippling limitation: a lack of range. The first of these guardians was the Lockheed P-38 Lightning. It was a revolutionary aircraft for its time, with a distinctive twin-boom design and two powerful Allison engines. It was fast, climbed well, and packed a concentrated punch of firepower in its nose, 4.50 caliber machine guns, and a 20mm cannon. In the Pacific Theater, against Japanese aircraft, the P-38 had proven to be an exceptional long-range fighter. However, the operational conditions in Europe were vastly different. The Allison engines, while reliable at lower altitudes, suffered from significant performance degradation in the thin, frigid air above 25,000 feet, precisely where the heavy bombers operated and the most intense air combat took place. Furthermore, early models were plagued by technical issues in the cold European climate, including problems with cockpit heating and engine troubles that made long-range missions over enemy territory exceptionally hazardous for the pilot. While it served with distinction, particularly with the 9th Air Force in a ground attack role and in the Mediterranean, the P-38 was not the ultimate solution for escorting the 8th Air Force's bombers to Berlin. The other primary American fighter in the theater was the Republic P-47 Thunderbolt. In many ways, the Thunderbolt was the polar opposite of the sleek and elegant German fighters it was designed to combat. It was a behemoth, the largest and heaviest single-engine fighter of the war. Pilots affectionately called it the Jug, short for Juggernaut, and the name was fitting. Built around a massive Pratt & Whitney R2800 double wasp radial engine, the P-47 was incredibly rugged. Its airframe could absorb an astonishing amount of punishment and still bring its pilot home. It was fast, especially at high altitude, thanks to its sophisticated turbo supercharger system, and it could outdive anything in the sky. Armed with 8.50 caliber machine guns, its firepower was immense. In a dogfight, a well-flown Thunderbolt was a fearsome opponent. However, the Thunderbolt's great strength, its powerful, thirsty engine, was also its greatest weakness. Its internal fuel capacity was modest for such a large aircraft, and its combat radius was severely limited. On a typical mission, a P-47 squadron could escort the bombers from England, across the Channel, and perhaps as far as the German border. But there, just as the Luftwaffe fighter opposition was beginning to intensify, the Thunderbolts would reach what their pilots called their point of bingo fuel, the minimum level required to make it safely back to base. They would be forced to turn for home, leaving their charges, the big friends, to fend for themselves for the most dangerous part of their journey. The search for a solution centered on a simple concept: carrying more fuel. The most promising avenue was the development of external, disposable fuel tanks, known as drop tanks. These were auxiliary tanks fitted to the wings or fuselage that could be jettisoned once their fuel was consumed, or when the fighter needed to engage in combat. Freeing the aircraft from the weight and drag of the empty tanks would restore its agility and performance. Engineers on both sides of the Atlantic worked feverishly on this technology. They experimented with tanks made of plywood and even compressed paper to conserve strategic materials like aluminum. The results were gradual but significant. With the addition of a single drop tank, a P-47's range could be extended. Later, with 2 wing tanks, its reach grew even further. By late 1943, improved models of the P-47, equipped with more efficient engines and larger drop tanks, were able to push deeper into Europe. They began to provide escort coverage further along the bomber's route, and the bomber crews greeted their presence with immense relief. The sight of the burly Thunderbolts weaving above their formations was a profound morale booster. For the first time, the Luftwaffe's company front attacks were being met head-on by capable American fighters. The tide was beginning to turn, but it had not yet fully shifted. Even with these improvements, the range was still marginal. Escorting the bombers all the way to targets in eastern Germany and back was stretching the P-47 to the absolute limit of its endurance. It required meticulous fuel management from the pilots and left no room for error or extended combat. The Thunderbolt, while a magnificent fighter, was a heavyweight brawler, not a long-distance marathon runner. It was a partial solution, a vital stopgap, but it was not the final answer. The Royal Air Force, facing a similar problem with its own bombers, had also contributed to the search. Their primary single-engine fighter, the Supermarine Spitfire, was a masterpiece of design, a brilliant short-range interceptor, but it had even less range than its American counterparts. The British response was typically innovative. They developed long-range versions of their twin-engine de Havilland Mosquito, a wooden wonder that could often outrun German fighters. But the Mosquito was a multi-role aircraft, not a pure air superiority fighter designed to slug it out with swarms of FW-190s. The strategic situation remained precarious. The Allies were making progress, but it was incremental and costly. They had fighters that were tough, fighters that were agile, and fighters that were well-armed. But they lacked the one machine that combined all of these attributes with the single, overriding characteristic that the air war demanded: range. They needed an aircraft that could not just reach the fight, but could stay there. An aircraft with the legs to go the full distance, to escort the bombers from their takeoff in England to the target and all the way back home. They needed a fighter that could sweep the skies clear of the Luftwaffe, not just over the coast, but over the heart of Germany itself. The stage was set for the arrival of a new player, an aircraft that had been conceived for a different purpose, but was about to be transformed into the ultimate long-range escort fighter. Its development was a story of international cooperation, engineering genius, and a fateful decision to combine a brilliant American airframe with a legendary British engine. This new machine would not just extend the reach of the fighter escort. It would fundamentally redefine the possibilities of air power and, in doing so, change the entire course of the war in the air. The search for a guardian was almost over. Section 4. The Birth of a Legend. The story of the P-51 Mustang, the aircraft that would ultimately solve the Allied escort crisis, begins not in the halls of the United States Army Air Forces, but with a pressing request from Great Britain. In 1940, with the Battle of Britain raging, the Royal Air Force was desperately seeking to bolster its fighter strength. They were looking to America's burgeoning aviation industry to supplement their own production of Spitfires and Hurricanes. A British purchasing commission approached North American Aviation, a relatively young but highly innovative company based in California. The British were interested in having North American produce the Curtiss P-40 Warhawk under license. The P-40 was a rugged and reliable fighter, already in service, but it was widely considered to be a generation behind the latest European designs, particularly in its high-altitude performance. The president of North American Aviation, James Dutch Kindleberger, and his chief engineer, Edwin Ned Northrop, made a bold counter-proposal. They argued that building the P-40 was a misuse of their company's talents. They were confident that they could design and build a completely new aircraft, one that was superior to the P-40 in every respect, and they could do it in an astonishingly short amount of time. The British, in desperate need of aircraft, agreed, but with a strict condition. A prototype had to be ready in just 120 days. It was a monumental challenge, but the team at North American was undeterred. The project, designated NA-73, began immediately. Ned Northrop and his team worked around the clock, fueled by caffeine and a sense of profound urgency. They drew upon the latest aerodynamic research, including data from a NACA, National Advisory Committee for Aeronautics, wind tunnel. Their design incorporated a revolutionary feature, a laminar flow wing. Unlike conventional airfoils, which were thickest near the leading edge, the laminar flow wing was designed to maintain a smooth, or laminar flow of air over a much larger percentage of its surface. This significantly reduced drag, which in turn translated into higher speed and greater fuel efficiency. The design was a masterclass in aerodynamic elegance. The fuselage was sleek and clean, and the air intake for the engine's radiator was placed in a unique ventral scoop under the belly. This scoop was ingeniously designed using the Meredith effect, where the heated air exiting the radiator actually produced a small amount of forward thrust, partially offsetting the drag it created. Every aspect of the aircraft was optimized for performance. In a remarkable feat of engineering and manufacturing prowess, the North American team met their deadline. The prototype, designated the NA-73X, was rolled out of the factory in just 102 days. It made its first flight on October 26, 1940. The initial flight tests confirmed what the designers had hoped. The aircraft was exceptionally fast and agile at low to medium altitudes. The British were impressed and placed a substantial order for the new fighter, which they christened the Mustang. The United States Army Air Forces, initially lukewarm to the project, also ordered a small number for evaluation, designating them the P-51. The first production Mustangs, equipped with the Allison V1 1710 engine, began to arrive in Britain in 1942. They were immediately put into service with the Royal Air Force, primarily in a low-level tactical reconnaissance and ground attack role. In this capacity, the Allison-powered Mustang, or Mustang Mark I, excelled. It was faster than both the Spitfire and the Messerschmitt Bf 109 at altitudes below 15,000 feet. Its long range and stable flight characteristics made it an ideal platform for rhubarb missions. Low-level sweeps over occupied France, attacking trains, airfields, and other targets of opportunity. American forces also used their version, the A-36 Apache Invader, a dive bomber variant of the P-51, to great effect in North Africa and Italy. However, the Mustang's great weakness was the very same one that plagued the P-38 Lightning, the Allison engine. The V1 1710 was a superb engine at low altitudes, but it was equipped with a single-stage, single-speed supercharger. As the Mustang climbed into the thin air of higher altitudes, the engine's power dropped off dramatically. Above 20,000 feet, its performance became sluggish, and it was no match for the turbocharged German fighters that prowled the upper reaches of the sky. This limitation meant that the early Mustang was unsuitable for the one role that was most desperately needed: high-altitude bomber escort. The aircraft had the legs. Its clean design gave it impressive range even without drop tanks, but it lacked the high-altitude performance to protect the B-17s and B-24s. It was a thoroughbred racehorse that could not breathe in the mountains. For a time, it seemed that the P-51, for all its promise, was destined to be a niche aircraft, a low-level specialist. It was a good plane, but not the great, war-winning fighter the Allies needed. The bomber crews continued their lonely journeys, protected for only part of the way by the P-38s and P-47s. The pieces of the puzzle were there: a brilliant, aerodynamically advanced airframe with exceptional range potential, and a desperate strategic need for a high-altitude escort. The challenge was to connect them. The solution would come not from an American factory, but from a suggestion made by a Rolls-Royce test pilot who saw the potential locked within the Mustang's elegant design. He recognized that the American airframe was a perfect match for a British heart. This proposed transplant would be one of the most significant technological decisions of the air war. It was a marriage of engineering excellence from two nations, a combination that would unleash the Mustang's full potential and transform it from a promising design into the legendary Sky Guardian that would sweep the Luftwaffe from the heavens. The birth of the legend was complete, but its christening in the fires of high-altitude combat was yet to come. The stage was set for the arrival of the Merlin. Section 5. The Merlin's Heart. The transformation of the P-51 Mustang from a respectable low-level fighter into the undisputed king of the high-altitude skies is a story of inspired engineering and international collaboration. The key to unlocking the Mustang's hidden potential lay not in its airframe, which was already a masterpiece of aerodynamic design, but in its engine. The Allison V1 1710 engine was a solid and reliable power plant, but its single-stage supercharger was an anchor holding the aircraft down, preventing it from reaching the operational altitudes, where the crucial air battles for Europe were being fought. The stroke of genius came from across the Atlantic. Rolls-Royce, the legendary British engine manufacturer, had been perfecting its own liquid-cooled V12 engine, the Merlin. The Merlin was already the heart of the Spitfire and the Hurricane, the heroes of the Battle of Britain. But Rolls-Royce had not stopped there. They had developed advanced versions of the Merlin, specifically the 60 series, which were equipped with a revolutionary two-stage, two-speed supercharger. This sophisticated system was essentially a miniature air compressor with a gearbox. At low altitudes, it operated in its low-speed gear, providing a moderate boost to the engine. As the aircraft climbed and the air grew thinner, the pilot, or an automatic barometer in later versions, would engage the high-speed gear. This would spin the supercharger's impellers much faster, compressing the thin air and forcing it into the engine cylinders, allowing the Merlin to maintain its power output at altitudes where the Allison engine would be gasping for breath. A Rolls-Royce test pilot, Ronnie Harker, after flying an early model Mustang, was so impressed with its handling and aerodynamic qualities that he famously wrote a memo suggesting that the aircraft, if fitted with a Merlin 61 engine, would be a formidable high-altitude fighter. The idea was simple, yet profound. It was a proposal to give the American thoroughbred a British heart, one capable of breathing in the thin air of the stratosphere. The suggestion made its way through the channels of command, and soon, a small-scale experiment began. Several Mustang Mark I airframes were taken from the production line and flown to the Rolls-Royce facility at Hucknall. There, British engineers began the complex task of mating the Merlin engine to the Mustang's fuselage. It was not a simple bolt-on operation. The Merlin and the Allison were different in size and shape, requiring significant modifications to the engine mounts, the cowling, and the cooling systems. But the teams at Rolls-Royce, and, soon after, at North American Aviation, worked with incredible speed and ingenuity. The result of this Anglo-American collaboration was the P-51B and P-51C models, the B being built in Inglewood, California, and the C in a new plant in Dallas, Texas. They were virtually identical. The first flight of a Merlin-powered Mustang took place in late 1942, and the performance improvement was not just noticeable. It was staggering. It was a completely different airplane. The new Mustang could climb faster, fly higher, and was significantly faster than its Allison-powered predecessor, especially above 20,000 feet. Its top speed jumped to over 440 miles per hour at 30,000 feet, making it one of the fastest propeller-driven fighters in the world. It could climb to its operational ceiling with breathtaking speed, and once there, it retained the superb agility and handling that had characterized the original design. The United States Army Air Forces had been searching for a solution to their escort problem, and suddenly, here it was. The decision was made to mass-produce the new Merlin-powered Mustang. To meet the immense demand, the Packard Motor Car Company in the United States was licensed to build the Merlin engine, designated the V1657. This was a monumental undertaking, requiring the American company to retool its factories and master the intricate art of building the high-performance British engine to exacting standards. They succeeded brilliantly, and soon, a steady stream of powerful Packard Merlins was flowing to North Americans' assembly lines. The marriage of the North American airframe and the Rolls-Royce Packard engine was the perfect union of aerodynamic efficiency and high-altitude power. The Mustang's laminar flow wing, which provided low drag for long range, was now paired with an engine that could pull the aircraft through the thin air, where that efficiency mattered most. The result was a fighter that possessed a combination of traits no other aircraft of its time could match. It was incredibly fast, highly maneuverable, heavily armed with 6.50 caliber machine guns in the later D model. And, most importantly, it had the potential for enormous range. The pilots who transitioned from other fighters to the new P-51B were ecstatic. They found an aircraft that was responsive and forgiving, yet possessed a level of performance that felt limitless. The cockpit of the P-51BC models featured a birdcage-style canopy, which offered decent but not perfect visibility. This would be addressed in the subsequent P-51D model, which introduced the iconic bubble canopy, giving the pilot an unobstructed 360-degree view of the sky around him, a critical advantage in a swirling dogfight. The installation of the Merlin engine did more than just improve performance. It gave the Mustang its soul. The distinctive growl of the Allison was replaced by the smooth, powerful roar of the Merlin, a sound that would become a comforting symphony to the bomber crews and a terrifying harbinger to the Luftwaffe. The aircraft now had the heart of a champion, the stamina of a marathon runner, and the speed of a sprinter. It was the complete package. It could climb with the best German fighters, outrun them in level flight, and outturn them in many situations. It was an air superiority fighter in the truest sense of the word. And it still retained that one crucial, inherent advantage that stemmed from its original design: fuel efficiency. Its internal fuel tanks already gave it a combat radius that was superior to that of the P-47 or the Spitfire. This inherent long-leggedness was the foundation upon which the final, war-winning piece of the puzzle would be built. The Mustang now had the power to reach the high-altitude battleground. The next step was to give it the endurance to stay there, to turn a long reach into an unbreakable lifeline for the bomber streams. The Merlin's heart was beating strong, ready to power the Mustang on its journey into history. Section 6. The impossible range. With the Merlin engine providing the high-altitude power, the P-51 Mustang was transformed into a world-class fighter. It could meet and defeat the best of the Luftwaffe in the skies above 25,000 feet. However, the core problem, the tyranny of distance, still remained. While the Mustang's internal fuel capacity was impressive, it was not enough to provide continuous escort for a bomber mission to a target deep inside Germany, like Berlin or Munich, and then fight its way back home. The solution, which would ultimately make the Mustang the truly strategic weapon it became, was not a complex new technology, but the perfection and application of a relatively simple concept: the external drop tank. The idea of carrying extra fuel in jettisonable tanks was not new. Both Allied and Axis forces had been experimenting with them for years. But the challenge was to create tanks that were large enough to provide a decisive increase in range, yet were aerodynamic enough not to cripple the fighter's performance, and cheap and easy enough to be mass-produced and considered expendable. The engineering teams supporting the 8th and 15th Air Forces went to work with a singular focus. They developed a series of standardized drop tanks for the Mustang, typically made of stamped metal, or, in some cases, a form of plastic-impregnated paper to conserve aluminum. These tanks were designed to be fitted to hardpoints under each wing, connected to the aircraft's fuel system via a series of pipes and valves. The pilot would typically use the fuel from the external tanks first. This had two benefits. It preserved the fuel in the main fuselage and wing tanks for the return journey and for combat, and as the external tanks emptied, the aircraft's center of gravity remained stable. The most common sizes of these drop tanks were 75 gallons and 108 gallons. With a pair of 75-gallon tanks, the Mustang's combat radius was extended to an incredible degree, allowing it to accompany the bombers far deeper into enemy territory than ever before. With the larger 108-gallon tanks, its range became truly intercontinental. A P-51 Mustang, carrying its full internal fuel load of approximately 184 gallons, plus two 108-gallon drop tanks, was carrying a staggering amount of fuel for a single-engine fighter. This brought its total fuel capacity to over 400 gallons, giving it a potential ferry range of well over 2,000 miles. More critically, it gave it a combat radius of over 850 miles. This was the magic number. It meant that a Mustang taking off from a base in eastern England could fly with a bomber stream all the way to Berlin, engage in combat with Luftwaffe fighters for a significant period, and still have enough fuel to escort the bombers back out of German airspace and return safely to base. This was the impossible range that had eluded the Allies for so long. The long, lonely journey of the bomber crews was finally over. The operational use of these drop tanks required a new level of discipline and tactical thinking from the fighter pilots. The flight to the target area was a careful exercise in fuel conservation. The pilots would fly at an optimal altitude and power setting, leaning out their fuel mixture to get the most mileage from every precious gallon. The Mustang, with its drop tanks attached, was heavier and less nimble. It was not in a position to dogfight. The primary mission during the outbound leg was protection, to act as a visible deterrent, a shepherd guarding its flock. The moment of truth came when enemy fighters were sighted. Before entering the fray, the Mustang pilots would reach down and pull a handle in the cockpit. With a clunk and a whoosh, the release shackles would open, and the empty or partially empty drop tanks would fall away from the wings, tumbling down towards the earth. In that instant, the Mustang was transformed. Freed from the weight and drag of the external tanks, it became the thoroughbred fighter it was designed to be: fast, agile, and deadly. The pilot could now push the throttle to the firewall, confident that he had a full load of internal fuel to fight with and to get him home. This simple act of jettisoning the tanks was a critical tactical pivot, the moment the Mustang switched from a long-range guardian to an aggressive hunter. The impact on the German fighter pilots was profound and demoralizing. For years, their tactics had been based on a simple, reliable timetable. They knew precisely how far the Allied escorts could penetrate. They would wait patiently, sometimes orbiting just out of range, watching as the P-47s or Spitfires reached their limit and were forced to turn back. That was the signal for the German fighters to pounce on the now defenseless bombers. But with the arrival of the long-range Mustang, that timetable was thrown into chaos. German formations would rise to intercept the bombers deep within their own airspace, expecting an easy engagement, only to be ambushed by swarms of P-51s that, according to all previous logic, should have been long gone. The psychological shock was immense. There was no longer a safe zone for the Luftwaffe. The Mustangs were everywhere. The phrase, "impossible fuel tanks," began to circulate, a reflection of the disbelief and frustration felt by German commanders. They could not understand how these single-engine American fighters were able to appear over Berlin and still have the fuel to fight aggressively. It seemed to defy the known laws of aviation and logistics. It felt like a magic trick, a technological advantage that they simply could not counter. A Mustang pilot's mission was now an endurance test of epic proportions. A long-range escort mission could last for 8, 9, or even 10 hours. An incredibly long time to be strapped into a cramped cockpit, constantly scanning the skies, enduring the cold, the noise, and the ever-present tension. These missions pushed both man and machine to their absolute limits. Pilots returned exhausted, dehydrated, and mentally drained. But they had accomplished the mission. They had stayed with the big friends. The combination of the Mustang's inherent fuel efficiency, the high-altitude performance of its Merlin engine, and the simple but brilliant solution of large-capacity drop tanks created the ultimate strategic weapon of the air war. It was a synergy of design and technology that solved the single greatest obstacle to the Allied strategic bombing campaign. The fortress now had its shield, a shield that could extend its protection all the way to the heart of the enemy's defenses and back again. The impossible had become a reality, and with it, the balance of power in the European air war was about to shift, decisively and permanently. Section 7. The Shepherd arrives. The arrival of the Merlin-powered P-51 Mustang in the European theater of operations in late 1943 was not a sudden, dramatic flood, but rather a steady, growing stream that would soon become a torrent. The first units to receive the new fighter were veteran groups within the mighty 8th Air Force, pilots who were intimately familiar with the brutal realities of bomber escort and the limitations of their previous aircraft. Among the first and most famous of these was the 4th Fighter Group, a unit with a unique and storied history. The 4th was composed largely of American volunteers who had flown with the Royal Air Force in the Eagle squadrons before the United States officially entered the war. They were seasoned, aggressive, and highly skilled combat pilots who had been flying Spitfires and later P-47s. When they began to trade in their heavy, rugged Thunderbolts for the sleek, new Mustangs, the transition marked a turning point. The initial reaction from the pilots was one of sheer exhilaration. They were accustomed to the raw power and diving speed of the P-47, but the Mustang offered a different kind of performance. It was a finely tuned instrument, incredibly responsive to the controls, with a rate of climb and agility at high altitude that felt revolutionary. They finally had an aircraft that could not only match the German fighters in a turning dogfight, but could also outperform them in many respects. The first long-range escort missions with the P-51B models began in December of 1943. These early missions were a process of discovery, as pilots learned the new tactics and fuel management techniques required for these marathon flights. They pushed the boundaries of their operational range, escorting the B-17s and B-24s further and further into Germany. For the bomber crews, the appearance of these new, unfamiliar fighters flying alongside their formations was a source of immense hope and relief. For years, they had become accustomed to the heartbreaking moment when their little friends would have to depart. They knew that the most dangerous part of their journey was about to begin. Now, as they crossed that invisible line deep inside enemy territory, they looked out their windows and saw that the escorts were still there. The sleek, shark-like silhouettes of the Mustangs, weaving a protective screen above and around the bomber boxes, were the most beautiful sight in the world. The intercoms on the bombers would crackle with excited, relieved voices. The presence of the Mustangs was more than just physical protection. It was a profound psychological boost. It meant they were no longer alone. It meant that someone was watching their back all the way to the target. The effect on the Luftwaffe was immediate and jarring. German fighter controllers and pilots, accustomed to a predictable pattern of engagement, were suddenly faced with a new and unsettling reality. Their interception plans, which relied on attacking the bombers after the short-range escorts had departed, were now obsolete. They would rise to attack the bomber stream over central Germany, only to be met head-on by aggressive formations of Mustangs. The first major test and demonstration of the Mustang's strategic impact came in the spring of 1944. The 8th Air Force launched a series of massive raids against targets in and around Berlin, a campaign that became known as Big Week. These were the deepest penetration missions yet attempted, a direct challenge to the heart of the German air defense system. And this time, the bombers did not go alone. Hundreds of P-51 Mustangs, along with long-range P-47s and P-38s, now equipped with better drop tanks, formed a massive protective shield for the bomber armada. The ensuing air battles were among the largest and most ferocious of the war. But the dynamic had fundamentally changed. Instead of German fighters preying on defenseless bombers, they found themselves locked in swirling, high-altitude dogfights with superior numbers of high-performance American fighters. The Mustang pilots, freed from the defensive posture of close escort by new tactical directives from commanders like General James Doolittle, were now authorized to be more aggressive. They were instructed to fly ahead of the bomber stream, to sweep the skies, and actively hunt for the Luftwaffe. The Shepherd had not just arrived to guard the flock, it had arrived to hunt the wolves. This new strategy, known as a fighter sweep, was devastatingly effective. The Mustangs would seek out and break up the German fighter formations before they could even get close to the bombers. The German pilots, many of whom were younger and less experienced than the aces of 1942, were overwhelmed. They were forced to fight for their own survival, drawing their attention away from their primary mission of destroying the bombers. For the first time, the 8th Air Force was able to strike targets anywhere in Germany with loss rates that were considered sustainable. The era of the 25% loss mission was over. The change was palpable in the briefing rooms and Nissen huts back in England. The bomber crews returned from missions to Berlin with stories not of relentless attacks, but of seeing epic dogfights far above them, of watching the Mustangs chase down and drive off the enemy. The mood shifted from one of grim endurance to one of growing confidence. The air war was still dangerous, and losses still occurred, but the odds had tilted decisively in their favor. The P-51 Mustang, in just a few short months, had completely rewritten the rules of aerial combat over Europe. It had fulfilled its promise as the long-range guardian the Allies had so desperately needed. The arrival of the Shepherd did not just save the bomber campaign, it turned the tables on the Luftwaffe. The hunter was about to become the hunted, and the skies over Germany were about to become the most dangerous place in the world for a German fighter pilot. The path to air supremacy was now clear. Section 8. The hunters become the hunted. The strategic shift brought about by the long-range P-51 Mustang was nothing short of a revolution. Before its arrival, the German Luftwaffe held nearly all the advantages. They fought over their own territory, guided by sophisticated ground control, with the ability to choose the time and place of engagement. Their pilots could land, refuel, and rearm at nearby airfields, while Allied pilots faced a long and perilous journey home if their aircraft was damaged. The Luftwaffe pilots were the hunters, and the Allied bombers were their prey. By the spring of 1944, this dynamic was completely and irrevocably reversed. The hunters had become the hunted. The psychological impact on the German fighter pilots cannot be overstated. Imagine a pilot, trained in the art of interception, taking off from his home airfield to engage an enemy bomber stream. For years, the script was the same: climb to altitude, wait for the short-range escorts to turn back, and then commence the attack on the vulnerable fat cats. Now, as they climbed, they were the ones being ambushed. The Mustangs were waiting for them. American fighter groups, no longer tied to the immediate vicinity of the bombers, were released to roam freely. They would fly ahead of the main bomber force, positioning themselves between the sun and the known German fighter assembly points. As the Bf-109s and Fw-190s climbed to meet the bombers, they would suddenly find themselves attacked from above and behind by swarms of P-51s. The element of surprise, once a key Luftwaffe advantage, was now gone. The skies over their own homeland had become a lethal trap. The Mustang was not just a defensive weapon. It was an offensive instrument of air superiority. Its combination of speed, altitude performance, and maneuverability made it a deadly opponent. While a well-flown Fw-190 could still be a formidable adversary, the Mustang could generally hold its own, or even surpass its German counterparts, especially at the high altitudes where the engagements took place. Furthermore, the Americans now had the advantage of numbers. The industrial might of the United States was producing Mustangs at a staggering rate, ensuring that the 8th and 15th Air Forces could put hundreds of fighters into the air for a single mission, overwhelming the dwindling resources of the Luftwaffe. This new reality gave rise to a new generation of American aces, pilots who mastered the Mustang and used it to devastating effect. Men like Francis "Gabby" Gabreski, a veteran who had flown with Polish pilots in the RAF, became legendary figures. Gabreski's tactical brilliance and aggression in the air were perfectly suited to the Mustang's capabilities. Robert S. Johnson, another leading ace, and Clarence "Bud" Anderson of the famed 357th Fighter Group, known as the Yoxford Boys, showcased the sheer dominance of the aircraft. Anderson, flying his iconic Old Crow, was a master of aerial combat, a pilot who understood how to exploit every ounce of performance from his machine. These pilots, and hundreds like them, were no longer just defending bombers. They were systematically dismantling the German fighter force, pilot by pilot, aircraft by aircraft. The German aces of old, the experienced Experten, who had once ruled the skies, were now facing impossible odds. They were forced to fly more and more sorties against an ever-increasing tide of Allied fighters. Even if they survived one engagement, they would land, refuel, and be sent right back up into a sky teeming with Mustangs. The attrition rate for experienced Luftwaffe pilots became catastrophic. A pilot's life expectancy, once measured in years, was now measured in weeks, or even days. For every experienced German pilot lost, he was replaced by a teenager with minimal training, sent up in an aircraft he barely knew how to fly, to face the best-trained and best-equipped fighter pilots in the world. The quality gap, which had once favored the Germans, was now a chasm. The German pilots began to refer to the ever-present American fighters with a sense of dread. The Mustang, in particular, earned their grudging respect and fear. They recognized its superb performance and the skill of the pilots flying it. The air war had devolved into a brutal war of attrition that the Luftwaffe simply could not win. American tactical doctrine also evolved. Pilots developed the Zemke fan, a tactic where fighter squadrons would spread out in a wide arc in front of the bomber stream, clearing a safe corridor hundreds of miles long. Any German fighter attempting to get through this screen would have to face multiple waves of Mustangs. The Allied fighters also began to follow the German interceptors back to their own airfields. As German pilots attempted to land, low on fuel and ammunition after a grueling fight, they would be pounced upon by Mustangs that had been waiting for them. This tactic, while risky, was incredibly effective, destroying aircraft on the ground and creating a state of constant peril for the Luftwaffe. There was no sanctuary. The front line was no longer over the English Channel. It was at the runway threshold of every German airfield. The reversal of fortunes was total. The Allied bomber crews, who had once been the hunted, were now witnesses to the systematic destruction of the force that had tormented them for so long. They flew their missions with a newfound sense of security, their confidence bolstered by the constant, reassuring presence of their little friends. The sky, once a place of terror, had become a workspace. The roar of the Merlin engines in the escorting Mustangs was the sound of safety, the sound of control, the sound of impending victory in the air. The German shield had been broken, and now the sword was striking at will. Section 9. The Crumbling Shield. The systematic destruction of the Luftwaffe's fighter arm by the P-51 Mustang and its long-range counterparts throughout 1944 was not just a tactical victory. It was a strategic catastrophe for Germany from which it could never recover. Air superiority is not merely about shooting down more enemy planes. It is about controlling the sky to such a degree that one can conduct military operations on the ground and in the air without prohibitive interference. By the summer of that year, the Allies had not just contested German air superiority, they had seized it completely. The consequences of this shift were felt in every aspect of the German war effort. The most immediate and obvious impact was on the strategic bombing campaign itself. With the Luftwaffe's fighter shield in tatters The 8th Air Force from England and the 15th Air Force from Italy could roam over Germany almost at will. They could attack any target they chose: synthetic oil refineries, aircraft factories, railway marshalling yards, with a level of precision and persistence that had been impossible just a year earlier. The loss rates for the bombers plummeted. While still a dangerous occupation, flying a B-17 over Germany was no longer the near-certain journey to oblivion it had once been. Missions that had previously cost 50 or 60 bombers now saw losses in the single digits, often due to anti-aircraft fire rather than fighters. This allowed the Allies to intensify the pressure, launching 1,000-bomber raids day after day, systematically grinding Germany's industrial capacity into dust. The German economy, already strained by years of war and a multi-front conflict, began to collapse under the relentless aerial assault. The production of tanks, aircraft, and ammunition faltered, starved of fuel, raw materials, and the components produced by factories that were now little more than smoking ruins. Perhaps the most critical strategic consequence of Allied air supremacy was its role in the success of the Normandy landings in June 1944. Operation Overlord, the amphibious invasion of France, was the largest and most complex military operation in history. Its success depended on the ability to land hundreds of thousands of troops and their equipment on hostile shores, and to supply them in the face of determined enemy resistance. This would have been impossible under a contested sky. In the weeks and months leading up to D-Day, Allied fighters, led by the Mustangs, conducted a massive campaign to isolate the battlefield. They swept the skies of northern France, ensuring that the Luftwaffe could not gather the strength to interfere with the invasion fleet. They attacked railways, bridges, and roads, preventing the Germans from moving reinforcements and supplies toward the Normandy beachhead. On D-Day itself, the skies over the beaches were completely owned by the Allies. While thousands of Allied aircraft supported the invasion, the Luftwaffe was able to mount only a handful of ineffective sorties. The German soldiers in their bunkers looked up and saw a sky filled with enemy planes, a clear and demoralizing sign that they had been abandoned by their own air force. In the brutal fighting that followed in the Normandy hedgerows, Allied ground forces benefited immensely from this air supremacy. Fighter bombers, including P-51s and P-47s, acted as flying artillery, attacking German tank columns, troop concentrations, and command posts. A German officer captured during the campaign lamented that his forces could not make a move during daylight hours without being spotted and attacked from the air. The Mustang, designed as a high-altitude escort, proved to be a remarkably versatile and effective ground attack aircraft as well. The loss of experienced pilots was the most devastating blow to the Luftwaffe. An aircraft is a replaceable machine, but a skilled pilot with hundreds of hours of combat experience is an irreplaceable asset. Throughout 1944, the Luftwaffe lost several thousand of its best pilots. These were the men who formed the backbone of the Jagdwaffe. Their replacements were rushed through training, often with less than half the flight hours that had been standard earlier in the war. These young, inexperienced pilots were sent up against the battle-hardened veterans of the 8th and 15th Air Forces and were simply outmatched and overwhelmed. The result was a vicious cycle. High losses led to a greater need for pilots, which led to abbreviated training, which in turn led to even higher losses. By the time of the Battle of the Bulge in the winter of 1944, the Luftwaffe was a shadow of its former self. It could still put up a fight, especially when blessed by bad weather that grounded the Allied air forces. But it was no longer a strategic force capable of influencing the course of the war. Its shield had not just been pierced. It had been shattered into 1,000 pieces. The control of the sky allowed the Allies to see everything. Photo reconnaissance aircraft, often variants of the P-51 or the de Havilland Mosquito, could fly over Germany with near impunity, gathering intelligence on troop movements, industrial production, and the effectiveness of the bombing campaign. This information was vital, allowing Allied commanders to make informed decisions and to target their efforts with maximum efficiency. The victory won by the P-51 Mustang and its pilots was a victory that enabled all other victories. It crippled Germany's ability to wage war. It ensured the success of the Normandy invasion, and it saved the lives of countless bomber crewmen and ground soldiers. The crumbling of the Luftwaffe's shield exposed the entire German war machine to a relentless and unstoppable assault from the air, accelerating the final collapse and shortening the conflict in Europe. Section 10. The Legacy of the Sky Guardian. The P-51 Mustang has secured its place in the annals of military history as one of the most iconic and decisive aircraft ever built. It was more than just a successful fighter. It was a symbol of how a single technological innovation, applied at the right time and in the right place, can fundamentally alter the course of a global conflict. Its legacy is a testament to the power of design, the importance of strategic foresight, and the courage of the pilots who flew it into battle. The Mustang's story is a powerful lesson in synergy. It was the product of a perfect storm of brilliant ideas: North American aviation's advanced aerodynamic airframe, Britain's revolutionary Rolls-Royce Merlin engine, and the simple but transformative concept of the long-range drop tank. None of these elements alone would have been enough. It was the combination of all three that created the war-winning weapon. The laminar flow wing provided the efficiency for long-distance flight. The Merlin's two-stage supercharger provided the power to fight and win in the thin air of the stratosphere. And the drop tanks provided the impossible range that allowed the Mustang to project that power all the way to Berlin and beyond. This combination of range, speed, maneuverability, and firepower, with its ultimate armament of 6.50 caliber machine guns, made the Mustang the ultimate air superiority fighter of its day. For the men of the Luftwaffe, it became a harbinger of defeat. For the Allied bomber crews, it was their salvation. The phrase, "impossible fuel tanks," perfectly captures the strategic shockwave the Mustang sent through the German high command. It represented a problem for which they had no answer. It nullified their geography, their defensive systems, and their years of tactical experience. The arrival of the Mustang meant that there were no more safe havens, no more rear areas in the air war. The entire sky over the Reich had become the front line. The strategic impact of this reality was immense. By achieving total air supremacy, the P-51 enabled the success of the Allied land campaigns, from the beaches of Normandy to the banks of the Rhine. It protected the bombers that systematically dismantled Germany's industrial might, and it choked off the supply of fuel that was the lifeblood of the German army's mechanized divisions. In this way, the victory won by the Mustang in the air directly and decisively accelerated the victory on the ground, ultimately shortening the conflict and saving countless lives on both sides. But the legacy of the Mustang is also a human one. It is the story of the engineers and factory workers who designed and built it with unprecedented speed and skill. It is the story of the mechanics and ground crews who worked tirelessly in the cold and mud of English airfields to keep the complex machines flying. And above all, it is the story of the young pilots who strapped themselves into its cockpit and flew for 8, 9, or 10 hours at a stretch, deep into hostile territory. They were the shepherds who guarded the flock, the guardians who finally gave the flying fortress its unbreakable shield. The P-51 Mustang stands as a powerful symbol of hope and ingenuity in a dark time. It demonstrated that even the most daunting strategic challenges could be overcome through innovation and international cooperation. It was not a weapon that began the war, but it was, without question, one of the key instruments that ended it. After the cessation of hostilities in Europe in May 1945, The Mustang's service was far from over. It went on to serve in the Pacific, and later, with distinction in the Korean War. It was flown by the air forces of dozens of nations around the world for many years. Today, the sight and sound of a restored P-51 Mustang flying at an air show is a powerful and evocative experience. The smooth, powerful roar of its Packard Merlin engine is more than just the sound of a vintage aircraft. It is the sound of history. It is the sound of a promise fulfilled to the bomber crews who once flew alone. It is the sound of the sky being reclaimed. The P-51 Mustang was the right aircraft at the right time, a legend forged in the crucible of conflict, a sky guardian whose legacy is etched forever against the vast canvas of the European sky.